Actually, I should have saved that as like my catchphrase from now. Don't get me started. So everything on the previous page is all stuff that you should already know. All right, so that's kind of good news, bad news. It would be good news if you happen to know all that stuff. It's not so good news if everything on that page looked like something completely new. All right, so you need to take some time and review those concepts. All right, I've been storing your packets in the back of the room all year for safekeeping, because I was a freshman in high school once, and you know, if you asked me in March where my Unit 1 packet was, best of luck to you. That's probably not a question that I would be able to answer. All right, so I've been hanging on to garbage would probably be the safest bet. All right. So if at any time you think you need review with some of the older topics and you want your packets back, I'm happy to give them to you. All right, so all you need to do is let me know. All right, but quadratic functions, the idea of solving equations, brand new. All right, in this context, because you don't know what a solution looks like based off of the graph. Now, solving just a quadratic equation. If I give you a quadratic equation, well, that was the subject of the whole unit of the we just tested on. But now it's related to a graph. So what do those solutions really represent? So Henry's really, really with me right now because I see he's bobbing his head. That's awesome. That's awesome.
Wait, you're wearing it. Wow. You're wearing it.
Exactly. Exactly. So
I think you're
the three whats were really good evidence of that. So vertex, the turning point of the parabola. All right, the parabola is the name of the graph of a quadratic. All right, so when we're talking about exploring graphs of quadratic functions, we're talking about characteristics of parabolas. All right, the axis of symmetry is a vertical line that splits the parabola in half. Zeros, roots, or solutions. Those are the x-intercepts. Average rate of change, or x-intercepts, sorry. Could have two of them, it's possible. Average rate of change is the slope between any 2 points on the curve. The story is here. All right, turning point, I think pretty easy to identify. There it is, right? All right, that turning point we call again a vertex. What are the coordinates of that vertex?
4, 5.
4, -5. All right, so if you have a nice looking graph, very easy to pick that information out. You can also sometimes get it from the table of values used to create the graph. You see in the example below, you're given a graph, you're given part of a table, but you're not given the equation. The reason you're not given the equation is because they don't want you just going right into the calculator and stealing the information. They want you to actually analyze the picture. All right. Next up is the axis of symmetry, vertical line that splits the parabola in half. Good news about this is, if you know that the vertex is going to be right smack dab in the middle of the parabola, then the vertical line that splits it in half has to go through the vertex. So I can draw, I'll do it as a dashed line here. I'm doing that on purpose because whenever you draw something as a dashed or dotted line or curve on a graph, it means that it creates a boundary, it gives you a sense of scale, but it doesn't actually exist as part of the graph. All right, so just giving us a sense of where the fold would be if you were to try to fold this upon itself. All right, but that's our axis of symmetry. Vertical line, so x equals what? A of s, so axis of symmetry. X equals what?
4.
4. All right, so the good news that comes out of this is the idea that if you already have your vertex, then you already know your axis of symmetry. It's x equals whatever the x value is. That's pretty nice. Next up would be the roots, the zeros of the function. So I got one right meh and one right meh. So I got a root here and a root here. If they're clean, that's good news. All right, so my roots, also known as zeros, would be x equals what and what? 1 or 7. All right, so we could pick that information off a graph, but then a good question would be, well, what if my vertex isn't clean? What if it's not 4? What if it's like 4 radical 2? I'm not going to be able to pull that off of a graph. Right? So is there some way in which I can come up with the axis of symmetry in the vertex without having to look at the graph? There is a formula. It's a nice formula. Compared to some of the formulas that we work with, it's pretty simple. X equals negative b over 2a.
This is for the axis of symmetry?
This is for your axis of symmetry. We actually don't really need a formula for anything else. Or at least we don't need a new formula for anything else. Right, x equals negative b over 2a will get us the axis of symmetry. But also, if you really think about it, the axis of symmetry splits the parabola in half, right? Doesn't that look like it's smack dab in the middle between the two roots?
It's one root A and the other root B?
The one root could be, well, no, actually the A and B come from whatever the quadratic equation you're given is. But what you could do, if you already know the roots, just find the average of them, and that'll put you right in the middle. And that'll give you your axis of symmetry. So sometimes you don't even need that formula, even if you are doing it algebraically. All right. So looking at the example below, and slope, it all depends on what the question's asking. In the example in this area, we don't really have any information to go for that. Axis of symmetry, well, it all depends on what the table tells us. What I'm going to help you do, at least before time's up, is help you complete this table. Because we have some x values. If you follow the trend here, -1, then the 2, then the 4, what two values would be in between -1 and 2? 0 and 1, assuming we're going by integer values. And then once you realize you're going with consecutive values, then you're in good shape. What y value would go with the x value of 0? 3. What about the x value of 1? 0. What about the x value of 3? You're just looking at the picture. At the x value of 1, we have a y value of 0. What about 3? 0. And what about the 5? 8. Notice how in your y column here you have symmetry. Top matches bottom, second from the top, second from the bottom, and so on. That information should be all you need to figure out everything that follows. If you have your grade slips, just leave them on your desk. I'll get them.